Hi dear students, once again welcome back to our channel. In this video, I am giving the full concept of quadratic equation, that is chapter 4. Okay, and we are familiar with what is a quadratic polynomial. That means a polynomial of degree 2 is what we call a quadratic polynomial, isn't it? Degree 2 means the highest power of the variable. Okay, and also we are using a single variable in polynomials. Okay, and for example, if I am giving a polynomial in x and that can be represented by p of x, and that means the variable in that polynomial is x. Okay, and for example, 3x square minus 2x plus 6. Okay, this is a quadratic polynomial because here the variable, single variable x, and the highest power of that variable is 2. Okay, and how can we reach from this quadratic polynomial into quadratic equation? Okay, and for that children, we know that a quadratic polynomial has two zeros. Okay, and how will we get the zeros of the quadratic polynomial? We have to equate the given polynomial into 0. P of x equal to 0 will give you the zeros of the polynomial. Okay, and we know that, let it be alpha and beta are the zeros of this polynomial p of x, and for getting that we have to equate p of x into 0. That means this 3x square minus 2x plus 6 equal to 0 in order to get the zeros, that is alpha and beta. That means if you substitute that alpha and beta in the given polynomial, that will satisfy. That means LHS equal to RHS. That is the meaning of zeros of the polynomial. Understood? That means if we equate that p of x into 0, if a polynomial is equal to something, okay, that means that quadratic polynomial turned into quadratic equation. Or here 3x square minus 2x plus 6 equal to 0 is a quadratic equation. That means we have equated that quadratic polynomial into a quantity, that is 0. Okay, if we have this example, children, 3x square plus x minus 2 equal to 7. Okay, and for that children, we have to take this constant, that is 7, that is RHS, that is 7 into LHS. That means you can equate in that case that RHS into 0. That means what I meant is 3x square plus x minus 2 and 7 come to LHS, minus 7 minus 2 minus 7 minus 9 equal to 0. Okay, so this is the standard form of the quadratic equation. That means we have to equate this RHS into 0. Okay, if any constant comes in the RHS or any variable, that is if we have here plus 2x, that means you have to take this 2x to LHS and that will combine with x, and that and also this constant 7 can be taken to LHS so that you can equate this RHS part into 0. Understood? That is a general form of a quadratic equation. Okay, so we can write in this step, you can write the general or the standard form of a quadratic equation. Okay, and we know what is the general form of a quadratic polynomial, that is p of x is equal to ax square plus bx plus c. Here a, b and c are any real numbers provided a not equal to 0. Okay, if a equal to 0 becomes, that means this first term ax square term becomes 0. That means now it reduced into bx plus c, that is a linear equation, a linear polynomial. Okay, so the very important point is there should be a term in x square, then only its power will be 2. Okay, and from this you will get the general form or the standard form of a quadratic equation. That means if you equate this polynomial into 0, that means the polynomial here is the general form I have written over there. So ax square plus bx plus c equal to 0. This is the standard form of a quadratic polynomial or quadratic equation. That means if you equate a quadratic polynomial into 0, then you will get a quadratic equation. It is clear, children? Okay, and in the same way, that is the values of the variable which, so that point is clear, children? Yes. See here, so that point is clear? Yes. Now comes the zeros of the polynomial and what it will be in the quadratic equation. See, zeros or the solution, or here in quadratic equation we are using the another term, that is roots of the quadratic equation. Both are the same, roots equal to zeros, or together you can say using one word, that is solution. Solutions of a quadratic equation is nothing but the values which satisfy this given quadratic equation. Okay, let it be alpha and beta. See children, a quadratic equation will have at most 2 zeros because, or 2 roots. Okay, because its degree is 2. Okay, so that is why I have taken only 2 roots, that is, then let it be as alpha. So this point is clear children. Okay, see, after explaining, so this point is clear children? Yes. See, in the quadratic polynomial we have the zeros of the polynomial. Okay, what is zeros of the polynomial? In order to get the zeros of the polynomial, you have to equate that into 0. That is p of x equal to 0. Okay, p of x equal to 0. So children, this point is clear? Yes. See, in quadratic polynomial we have seen that it will have 2 zeros. Okay, and we know that in order to get the zeros we have to equate that p of x into 0. Exactly same way, that is, if p of x equal to 0 means that become quadratic equation, right? Okay, so we have 2 zeros in the quadratic equation also. But commonly we are using another term to denote the 0, and that is roots of the quadratic equation. Roots is equal to zeros, both are the same. Okay, zeros equal to roots, or you can express these two in another term, that is solution. Solution means the value of the variable which satisfies the equation. Okay, so all these three are the same idea. Okay, see children, since here we have the degree of the quadratic equation is 2, it will have at most 2 zeros or 2 roots. Okay, see, let it be alpha and beta. These zeros or roots of the quadratic equations we are usually representing with alpha and beta. Okay, and in quadratic polynomial we have seen that the sum of the zeros, that is alpha plus beta, equal to minus b by a. Minus b by a means here the b is coefficient of x and a is the coefficient of x square. Okay, see children, in quadratic equation there should be a term in x square. If a equal to 0, what happens children? This term will not be there. Then that equation reduced into linear equation, because here that terms remaining will be bx plus c. Here the variable is x and its degree is 1. So linear equation. Okay, so in order to make it a quadratic equation, the degree of the polynomial, the variable, the highest power will be 2. So definitely there should be a term with the variable x and its power must be 2. Okay, so here alpha plus beta, that is sum of the roots. Okay, and that will be equal to minus b by a, and that we have already seen in the polynomial, that second chapter, and the product of 0 alpha beta equal to c by a. That means constant divided by coefficient of x square. These all hold in this quadratic equation also. Okay, these all things we have discussed in polynomial, and the same result we can apply here in quadratic equation. Understood? Our next point is children, how to find out the solution of a quadratic equation. Here we have 3 methods to find out the solution of a quadratic equation, and the first one is factorization method and completing the square method, and finally the third method is using quadratic formula. Okay, and because of this COVID situation, that is second method, completing the square, is deleted. So we have to discuss only factorization method as well as the third method using the quadratic formula. How to find out the roots of the quadratic equation using factorization method, that we already discussed in the smaller classes, just like splitting the middle term. Okay, for that children we have a quadratic equation such that 2x square plus 5x plus 3 equal to 0. This is a quadratic equation. See children, here in quadratic equation you have to express using one single variable, then only it will become a quadratic equation. Just like quadratic polynomial, p of x means the polynomial in x, only single variable. Okay, so in the word problems, that is if we have a situation, you have to express those situation using one single variable. That is very, very important. Then only you can apply these methods to get the their respective roots of the quadratic equation. Okay, see, using this factorization method or the splitting the middle term that we have used in the previous classes. Okay, and for that you compare with the general equation ax square plus bx plus c equal to 0, and you consider, take the product AC. Okay, that means the coefficient of x square and the constant term, that is AC, that is 2 into 3, that is equal to 6. You have to break down this 6 into 2 factors such that their sum should be the coefficient of this middle term, or that second term, that is coefficient of the x in this case. Okay, that is 5. And for that, that factors of 6, you can take 1 and 6, but if you are taking these two, that will not satisfy our second requirement. Okay, the sum must be 5. Okay, so the second pair is 2 and 3. See children, the product will be 6, and if you add, that is 2 plus 3, that is equal to 5. Okay, so hence you can split this middle term and such a way that 2x square plus 2x plus 3x plus 3 equal to 0. Then you can, what you can do children, you can take the common factors, that is 2x from both the term first group. So you will be getting x plus 2 plus the second group you can take 3. So x plus 1 equal to 0. Okay, 2x taking, you will be getting 2x plus 1 in the bracket, and here again x plus 1 common. Okay, and you will have 2x plus 3 equal to 0, or you can equate each factor into 0. So x plus 1 equal to 0, hence x equal to minus 1, and 2x plus 3 equal to 0, hence you will get 2x is equal to minus 3, or x is equal to minus 3 by 2. That means these two values of x are the roots of the quadratic equation. As I told, it will have exactly at most 2 zeros, and this x as alpha and this x is equal to be beta. So you will have minus 3 by 2, that is equal to alpha, and minus 1 equal to beta. These are the two values. When you substitute these values in this, you can make this RHS into 0. That is the meaning of the roots of the quadratic equation. Okay, so yes children, this is the way to find out that factors or the roots of the quadratic equation using factorization method. So the next method is using quadratic formula, how to get the roots of the quadratic equation. Okay, and see children, why we have the third method? So some cases it will be difficult to that split that middle term in order to get that zeros. Okay, and for that, if you know this formula, you can directly get these two values. Hence you can easily get alpha and beta. Okay, and for that, that formula is x is equal, x is the variable used in that particular quadratic equation. Okay, ax square, here the variable is x. So that is the meaning of, that is the value, that is the thing you have to write here in the LHS of this formula, and that is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. See children, all these variables are the coefficients of here a, b and c, x square, x and the constant term. See children, minus b, coefficient of x, and take its negative. Okay, plus or minus, both values you have to consider. Root of b square minus 4 is a constant. Okay, 4 into coefficient of x square, that is a, and the constant of b square minus 4ac divided by 2a. Using this, you can easily get this values, that is alpha and beta. That means the two roots of the quadratic equation. This is the quadratic formula or Sridharacharya's formula. Both are the same. Okay, using Sridharacharya's formula, how to find out the roots of the quadratic equation. Okay, without using this one, that is splitting the middle term or grouping method, these all steps you can avoid if you know this formula. This would be the better formula to get the roots of the quadratic equation. Okay, see children, we can take the same equation in order to give an example, okay, apply this equation, how this equation can be applicable for this, the given example, that is here a is equal to 2 minus b. Here comparing with, you will get a equal to 2, b equal to 5 and c equal to 3. You just compare the given equation, okay, with this general form, okay, and write a, b and c. Okay, and here a is here and we are going to substitute over here. So minus b is 5, so minus, its negative is minus 5 plus or minus b square root of b square, here b is 5 square, okay, minus 4 into a is equal to 2 and c equal to 3 divided by 2 into a is 2. Okay, so here minus 5 plus or minus square root of 5 square is 25 minus here 4 into 2 into 3 6, so 4 into 6 is 24 divided by 4 and minus 5 plus or minus 25 minus 24 is 1, root 1 is 1 divided by 4. So these are the values of x. And how can we solve this plus or minus situation? And for that, children, you take first the plus value, okay, and for that, children, x is equal to minus 5. I am considering the first sign, that is plus 1 divided by 4. Okay, that means minus 5 plus 1 is minus 4. Minus 4 by 4 is equal to 1. And in order to get the second root, this can be alpha, okay, and this can be beta, and for that you have to consider the negative sign, okay, and give both the signs separately in order to get the two roots, okay, and for that minus 5 minus 1 by 4, right? So you will get minus 5 minus 1 is minus 6 divided by 4, you can reduce minus 3 by 2, this is beta. If you know this formula correctly, see children how easy it will be, you can avoid all these steps. See children, both cases you got minus 3 by 2 and minus 1, here also minus 3 by 2 and minus 1, okay, minus 1, okay. So these are the roots of the quadratic equation, okay, using quadratic formula. That idea is clear children, okay, that means to find the solution of a quadratic equation, we have two formulas, two methods. Okay, one is factorization method, by that means using the splitting the middle term, and the second one is using quadratic formula, and this is that is x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So whatever the equation you are forming, okay, under the given situation in the word problems, you will be getting easily their roots using this quadratic formula. So I would suggest this formula, okay, in order to get the roots. Understood children? So we have one more topic in this quadratic equation, that is nature of roots. Okay, see children, see in the previous example we have seen that alpha equal to minus 3 by 2 and beta equal to minus 1. That means here we have both are different, alpha and beta different. Okay, that means two distinct zeros. Distinct means different zeros. And see children, if we have x square plus 4x plus 4 equal to 0, this is expanded form of x plus 2 whole square or x plus 2 into x plus 2 equal to 0. In this case, x is equal to minus 2, and the second factor when you equal to 0, in that case also you will get minus 2. That means alpha equal to minus 2, beta is equal to minus 2. That means two equal zeros, alpha and beta are the same. Okay, see children, that means how can we say that what will be the nature of the roots of the quadratic equation? And for that children, you just take b square minus 4ac. Okay, whatever the quadratic equation you are getting, find out b square minus 4ac. b square minus 4ac is, that means the coefficient of x square, coefficient of x, that is b, and 4 into coefficient of x square into constant term. Okay, and this b square minus 4ac will give you the nature of the quadratic equation. That means this is what we call the discriminant. That means it will decide discriminant. Okay, so if you find out b square minus 4ac and getting that answer, you can predict, you can say that the nature of roots of the quadratic equation. Okay, that means if b square minus 4ac, b square is nothing but the coefficient of x and 4 is a constant, a is the coefficient of x and c is the constant term. Find out by comparing the given equation with the standard form, you find out b square minus 4ac, okay, and if that is equal to 0, some cases equal to 0. Okay, and in some cases b square minus 4ac is greater than 0. This is exactly equal to 0. Okay, some case greater than the previous example we have seen that root 1, b square minus 4ac is 1. Okay, that is greater than 0. In some cases this b square minus 4ac is less than 0. These are the three situations. Okay, if b square minus 4ac equal to 0, in that case, okay, it will have two equal zeros. Okay, see children, here if you compare this with the general form b square minus, what will be b square minus 4ac of that one, b square, here b is equal to 4, okay, so 16 minus 4 into a, 1, and c is 4, that means 16 minus 16, 0, that means b square minus 4ac equal to 0, that means in that case, see children, both alpha and beta are the same, minus 2, that means two equal zeros. Two equal roots. Okay, if this is equal to 0, two equal roots. Understood? If b square minus 4ac greater than 0, in the previous example we have seen that b square minus 4ac equal to 1. That means in that case we got alpha as minus 3 by 2 and beta equal to minus 1. That means both are different. That means two zeros is there, two roots are there, but both are distinct, different. When we have b square minus 4ac equal is greater than 0. And if b square minus 4ac less than 0, in that case no real roots. Okay, this case we will discuss in the next year. Okay, so here we have only b square minus 4ac equal to 0. That means in that case two equal zeros. Okay, here if it is greater than two distinct zeros, two distinct, different, distinct zeros or roots. Okay, in this case, no real roots. No real roots. We have discussed the number system till real numbers. We have another number system also, complex number system and all. Okay, and that we'll discuss in the next year. Okay, so children, that is why this b square minus 4ac is what we call discriminant. That means it will decide the nature of the roots of the quadratic equation. Okay, and after that you, if it is greater than 0 or equal to 0, you just substitute, and so that you will be getting the zeros of the, or the roots of the two roots of the quadratic equation. Okay, if that b square minus 4ac equal to 0, children, this term is reduced into 0, root 0 is 0 itself. Okay, so in that case x is equal to minus b by 2a. Okay, that means alpha and beta both are the same. Okay, so you have to find out x is equal to minus b by 2a. Why? Because we have seen that b square minus 4ac equal to 0. That means this term reduced into 0. Under root we are writing this discriminant. What we are getting this b square minus 4ac, that we are writing under the square root. If that is equal to 0 means root 0. Understood? That is why this reduced in the form minus b by 2a. See children, that means x is equal to, in this example, minus b is equal to minus 4 by 2 into a. 2 into is, that is here 1, that is minus 4 by 2, that is minus 2. See children, being it is a quadratic, it will have two roots. Okay, that means you have to consider two values for x, and being b square minus 4ac equal to 0, those values will be same, that is two equal zeros. That means x is equal to minus 2 and minus 2. Okay, that means children, x is equal to minus 2 means x plus 2 equal to 0. That means by factor theorem. Okay, and being we have one more value for x, we need to express for x, values of x as minus 2, minus 2. In second case, that case also you will be getting second factor as x plus 2 equal to 0. Okay, so their product will be 0. If you are taking only these two as separate factors 2 times, then only after simplifying x plus 2 and x plus 2 you will be getting this quadratic. Okay, if you are taking only x plus 2 equal to 0, it will reduce into a linear equation. Okay, that point is very important, children. Being it is a quadratic, okay, it will have two factors, same factors, since b square minus 4ac equal to 0. Okay, then only after simplification you will be getting a quadratic equation. Okay, even if it has two equal zeros, equal roots, you have to write it 2 times, that is x is equal to minus 2, minus 2. Understood? So children, this is all about this quadratic equation, that all the remaining exercise we will solve in the coming videos. So thank you children, thank you for watching and supporting my channel.